I am a freelance web and mobile dev, and I'm going to talk to you about GraphQL today. I'll probably be picking up where Jonas left off this morning. I'll be trying to get through a lot, so I might be talking fast. And I also had caffeine today, which I don't normally have, and some sugar. There was these good cookies earlier. And if you're watching this online, go check out Jonas Helfer's talk before you watch this one. It was 10 minutes. Great guy. Good stuff. So, GraphQL. It's not a query language for querying graph databases. So we have a client, we have a server, and we have databases. And there are certain languages like SQL or like MongoDB, a query language that you talk to between the server and the databases. There's a and GraphQL is an option for how to talk between the server and the client. So if you are a website or a mobile app or an Arduino or a desktop app, and you want to talk to a server, you want to fetch data, you want to do RPCs, tell the server to do something. The best way to do that is not with REST, certainly not with SOAP. Best way to do that is with GraphQL. There are a number of ways in which it's better, and Jonas talked about some of them. Just a quick overview is it's easier to program the server instead of having lots of endpoints, maybe one for each view plus like standard /post /user /whatever. You have a single endpoint, and usually you have like a single function talking to a single database. And then on the client side, there's a few reasons why it's nicer to work with. One is that it's all in one request instead of multiple in series, like you would have with REST. Another one is that any GraphQL server you talk to has a built-in documentation that has an interactive IDE you can work in to build your query. Another reason why it's nice to work with on the client is when you're probably going to use a GraphQL client library, and that'll let you co-locate the parts of the GraphQL query that you're using for a certain component, like in React or Vue or Angular, with that component, so in the code. So like if you're doing a post component in React, in that same file you have the part of the query that is backing the data for that component, and then the library puts it all together in one big query that sends it in a single HTTP request to the server. Another benefit is oftentimes, or the most popular client libraries also have a normalized global cache on the front end, so that takes care of a lot of data stuff for you that would be taking you longer if you were doing like REST and Redux by yourself. It like does like if you have multiple views that have the same data and you go between them, you don't have to request the data. If it changes because you did a requery, that reactively updates all of your different views, even if there are like multiple views at that one piece of data that changed, depended on. So, is this on? Testing. Testing. All right. So we're going to continue with what Jonas talked about, having multiple data sources behind your GraphQL API. And someone shout at me when I have like a minute left, and I'll speed up or go to the end. So let's say we're doing not a blogging app, but a Twitter clone, because that's original. And we're going to have a big dashboard that's like your home login page, and it's going to have a few different things. And we're going to use 5 different data sources, and I'll just go through each one and say what part of the dashboard the data in that data source is going to power. First, we have Postgres. It's users and tweets is relational, so we're going to use a relational database to be the store of record. And then Redis, we're going to have a public feed, and so like all the most recent tweets from worldwide, and it's going to be queried a lot. And so we're going to get to it quickly, fetch it quickly because it's Redis, and we're going to reduce the load on Postgres. Then we have Elasticsearch. We want a list of all of the tweets that mentioned your name recently, and so we're going to use the search database for that. We could use Postgres, but we're going to prematurely optimize. REST. We're gonna hit a REST API for geolocation. We want to show all the most recent tweets in your city. And then MongoDB we're going to use for stats. So GraphQL there's like three major parts. There's the query, like what for each client that you have. It's a mobile app or a website or all of them. They each have their own set of data that they're querying for. So that's one part. The other part is the schema, which is defined on the server, which says to anyone out there in the world, these are the possible types that possible queries you can make and what types of data they return. And then there's the third part is the resolvers, the logic that says how to fetch what data from where. So for the schema, let's build it. That's the three sort of top level things that we need is we need to fetch a user, lowercase, we need a public feed, and we need a city feed. And a user, I need an argument like the ID, and it returns a user doc. So that's a type that I will define later. Public feed returns a list of tweets, and city feed is a list of tweets. Everything is typed including arguments, so I need to say what type of thing ID is, and it's int, scalar, basic defined type, and it's required, so it needs a exclamation point. Let's define what a user is because we have user in our definition and it doesn't know what a user is, so we need to define it. Type user, we could have first name, last name, a photo URL, and mentions. So on our dashboard we want all of the most recent tweets that mentioned your name. So this is going to be a list of tweets, and all the other ones will be strings. Everything needs a type. Yeah, okay. What's the last thing we haven't defined is a tweet. So let's do that under here. What data should the tweet have? Sorry. It should have the text of the tweet. When it's created, float because it's a long timestamp. How many views? Integer. What else? Let's see. City is also a string, and then we need to know the author, so it's going to point at the user type. So this is the whole schema for our Twitter clone, and what we do with this is we put it in a string, and no matter what your backend is, you're going to be using a GraphQL server library that takes that string and then does stuff with it. So here this is in JavaScript. We're doing a Node Express example server. We put in a string and export it, and then we use it during server setup. So we can actually use this, have it running locally with local Postgres or SQLite and Redis and Elasticsearch and Mongo, and we can see what the server does. So Jonas looked at this briefly. It's called GraphiQL. It's like an IDE for building your queries, and you can point it at any GraphQL endpoint and see what the options are. You can either use the docs tab over here, which is, okay, what types of queries can I do? I can find a user, public feed, city feed. User returns user. What is a user? It has these types. What's a tweet? It has all these things. Okay. So that's a really nice thing versus like if you were looking at a REST API, they have very different types of documentation and often it doesn't have like an interactive thing that you can try it out with. So it's a nice thing that's like standard across all GraphQL API endpoints. So I can do control space, yep, and it has the options. So these are the top level things. I want a user. I need to give it which user, and then I do command enter to autofill the scalar types of a user. And it returns null because I haven't defined any of the resolvers yet. We haven't done any of the logic. We've just done the types. So you can see that these types that are suggested here, like if I do control space again, I see mentions is also there. These are all coming from the schema I defined. User has first name, last name, photo mentions. So that's where they match up. Let's try fetching the user on the server. So here's our resolvers. So the functions that resolve a certain field, like that tells you what a user, how to fetch the user with ID 1, or how to do mentions, how to fetch mentions for a user. These are all functions called resolvers in GraphQL. And how do I get rid of this? Yeah, okay. So we're in a blank resolvers file that just returns null or empty arrays. We're importing some stuff from a connectors file. It's using SQLize ORM for Postgres. Mongoose is the most common node ORM for MongoDB, and then Elasticsearch client, Redis client. So we're importing that stuff over here. So the user and the tweet are the SQLize models, and then views is the Mongoose model. And we need to change this thing to something that works. And I don't have time to actually live code this, so let's paste it. So it's a user.find where ID equals args.id. So whenever I'm in a resolver, I get args over here. So like when I'm passing in user ID something, it's going to be args.id. So args.id is going to be 1 right here. So let's save it and rerun this query. And we get a user. So this over here is no longer null. It's Maureen Rao, I think is how you pronounce that. These are all like defined by the mocking library casual. But mentions is still blank. Okay, so what this did was it did like a select star on users table where user.id is args.id, and then it returned it in the server, returned it to this client app website, and then displayed it over here. And this isn't what you would be using in your app. Like if you're doing React, you'd be using the library, but this is just for development in the GraphQL IDE, for developing what query you want and what data fields you want. So for instance here, if I knew I didn't need the photo, I would take it out and I wouldn't get it. So that's another great thing about GraphQL is that the client is determining what data it gets. It's not like in REST, it's always the endpoint that decides what data is returned. So there's a lot of overfetching. Here, each client says what it wants. And the server just says, this is what I can give you. So what's next? Mentions is 5 minutes. All right. Mentions is an empty array. Let's try to fill it in. So we're working on the query. If you can see that the resolvers match up with the schema. Query has 3 different types: user, public feed, city feed. So user, public feed, city feed, and then within each of these types, user, you don't need resolvers for these because they're just scalar basic types coming out of the SQL row record. But mentions, it doesn't know, it's not stored in SQL. You don't have an array of tweets in SQL, so we need to do a resolver to say how to fetch mentions. So for in the user, look at mentions and do something. Where are mentions stored? They were in Elasticsearch. So let's copy that. This does an Elasticsearch.search and then just puts the user first name, last name together, and then returns the results wrapped in the ORM. When you're inside a resolver of a defined type that's not the query, you get whatever document you're inside. So user, we have access to the first name and last name, so we can put those together into the string search thing. So we save that, and we rerun it, and then we wait for the server to restart. All right, and now we have mentions. So this tweet mentioned Maureen Rao, which is why it came up in the Elasticsearch search. And what are the other things I can find, or what are the other data fields in a tweet I can fetch? The only one I'm missing right here is author. So let's look for the author. Author is null, views is null. That's because we haven't defined those resolvers yet. So we're inside the tweet type right now. So tweet has text, author, city, blah, blah, blah. The ones that were stored inside of Elasticsearch were the text, city, and created. Views, remember, we put in MongoDB, And the author, we have the author ID in Elasticsearch, but we need to look up the actual author in SQL. So the two places to do that are here and here inside of the tweet resolvers. So let's look at this one first. So this is the mongoose thing. We do a find one where the tweet ID matches, and then we just return the views integer. So if we rerun this, it's now pulling the 51 out of MongoDB, matching based on the tweet ID. And then for here, let's do return tweet.getUser, maybe? Yeah. So this is a SQLize, like I told it, it had a relation to user doc. So what it does is select star on users where tweet.author equals user ID is what that translates, the SQL query that translates to. And we get the author up here. Yay. What's next? We did the user top level query. We can also do public feed. Right now it's blank. Where's the public feed? It's in Redis. So here's public feed. Let's look in Redis for that feed. 2 minutes. All right. Thank you. Here's the public feed doing a Redis client L-range async. So we're looking in this list, and we're getting the range from the 0th index to the end. And then Redis stores strings, so we need to JSON.parse it to get the object back. And this list is trimmed down to 2 or 3 things. So we return the whole list of 3 things, and we go back to here and see if it works. And it does. We get a list of 3 tweets, and again, we can choose what we want to appear. So I'm taking out the city field and requerying, and it's not there anymore. Next, we can do the city feed. Let's take all this out and just do city feed. It's blank. Why is it blank? We haven't done it yet. And city feed was stored where? City feed is, the tweets are in SQL, but we need to figure out which city we're querying for. So we look at the HTTP request's IP address and doing a GET request to this API that returns JSON something like this. And the only thing we care about is the city. And so we take the city out of the response, and we do this is SQLized, so we do a SQL query of the most recent 3 things where the city matches, and then we return them. So what does this look like? Failed to fetch. Server's restarting every time I save the file. Here it is. So we got views created, and last thing is author. The interesting thing about this is oh, sorry. So that should work. The thing that was interesting was public feed. We couldn't get the author before. So yeah, the author was null here because in Redis we were storing the entire user doc as a subdoc, so we didn't have to do multiple queries because like we're using a cache, we might as well get it in a single thing. So it's like if tweet.user is already there, then we're going to return it. And there we go, the user. All right, so that is the entire. That's the entire server. If you want to see the rest of the code, it's pretty short. It was mainly those 2 files, the schema and the resolvers. The connectors has some like defining the models and seeding the database. You can read the entire. Okay, there's a hosted version of the GraphQL IDE that uses Compose hosted databases. Thank you, Compose. Here's the article that is a more verbose version of what I just presented. If you're doing this production, you might want to do some caching so you're not requesting things a lot. You can use DataLayer for that. If you want to do joins, use join monster, your SQL thing. I'm writing a book on GraphQL. If you'd like to sign up right over here on this website, GraphQL.guide. It's going to be great. It's going to teach you GraphQL in depth. And this is me. I'm a freelancer if you'd like to hire me. And that's everything.